In this lesson, we'll discuss quadratic inequalities. A quadratic inequality is just like a quadratic equation, but it has an inequality symbol, less than, greater than, less than or equal to, greater than or equal to, instead of the equal sign. If we have less than or greater than, the endpoints are not included in the solution. If we have less than or equal to or greater than or equal to, the endpoints are included in the solution. The equality means we include those endpoints. We're going to start this lesson with a look at graphs and then work to solve quadratic inequalities symbolically. Here we have the graph of x squared plus 4x plus 3. The first question that we have, where is f of x equal to 0? And a reminder, take that part out. Remember that where is really asking what x value or what x values does this happen. So at what x values is the function 0? Also recall that f of x is another way to write y. So what x values correspond to y equals 0? Looking on our graph, we can see that x equals -3 and x equals -1 are x coordinates that are on the graph whose corresponding y coordinates are equal to 0. So x equals -3 and -1. Question B asks, where is the function less than 0? Looking at our function here, less than 0 would be below the x-axis. And here we have the x-axis in a rainbow line, just to make it stand out. F of x less than 0 would be below that x-axis. So in this case, below the x-axis here is given by the x values between -3 and -1. So we can say x is between -3 and -1, or the corresponding interval notation, -3 to -1, using parentheses. Regarding the same graph, where is the function greater than or equal to 0? That would be above the x-axis. Looking above the x-axis, we have this first piece above, and then we also have a second piece above in yellow. These two pieces correspond to x being less than or equal to -3, or x being greater than or equal to -1. Yellow is looking at the x values less than -3, greater than -1. Since we have that equal sign in there, we want to include those values. If I write this as interval notation, since I'm running out of space there, I'll write it on the side. The interval notation would be -∞ to -3, including -3, or -1 to infinity. We are able to look at the graph and determine from the graph where the function equals 0, where the function is less than 0, or less than or equal to 0, and also where the function is greater than or equal to 0, or greater than 0. The difference between greater than and greater than or equal to is merely the indication of including the endpoints or not. Another example that we can look at, here's a graph of f of x is -x squared plus 4. Noticing from our quadratic chapter, the negative on the front, the negative a value, means our parabola opens downward, and we have that here. F of x is equal to 0 at the 2 points that cross the x-axis, -2 and +2. Calling out the x-axis again with our rainbow line, where is f of x less than 0? We can say less than 0 would be these branches that are going below the x-axis, and those branches occur when x is less than -2 or x is greater than +2. We can see those values here on our graph. Where is f of x greater than or equal to 0? We look for where the graph is above the x-axis, and above the x-axis is between -2 and 2. And we use the equal to signs because we have that equal to sign in our original inequality. If we're looking at interval notation, for less than 0, we have negative infinity to negative 2 and 2 to infinity. For greater than or equal to 0, we have negative 2 to 2. We're really just looking at where is the graph above the x-axis for greater than 0, and where is the graph below the x-axis for less than 0. Notice we have two different scenarios here, one where the parabola opens upward and one where the parabola opens downward. And these are the types of inequalities we're going to be focusing in this chapter, or inequalities represented by functions, and considering parabolas that open up or parabolas that open down.